Hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 3 of the daily Leetcode challenge for the April month, and we again have a medium question in front of us. Let's see what this question is. So it is word search question number 79. And by the way, like, see, whenever you see a question number like 79 or anything less than 100, so you can just have the feeling that these are the base question with which Leetcode started and it gained popularity. Okay, so there is definitely some worth solving this kind of questions which were part of Leetcode in its beginning. Okay, so this is one of them, question number 79. So let's see what this question is. So given a m cross n grid of characters board, so this is the basically name of the 2D matrix given to us, and there is a string called word given to us. Okay, ultimately we have to return true and false is the answer. Return true if word exists in the grid. Okay, the word can be constructed from letters sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. So this particular statement is very important when we are going to form the, we will see that now, but just understand that when we say adjacent, we actually mean either horizontal adjacent or vertical adjacent. Remember one thing, we are not considering the diagonally adjacent as the real adjacent here. Okay, so that is the only difference. Okay, either it should be horizontal or vertical, and we are not considering the diagonal one as adjacent here. Okay, so I will see that with examples, but let's complete the question. The same letter may not be used more than once. This is again a very important condition. You will have to, write a code for this. Basically, this follow statement needs a code. Okay, otherwise you will end up in a, endless for loop. Okay, yeah. Let us see the question now. Okay, so this is the 2D grid given to us. Okay, you can see here, and the word is given to is A B double C E D. Okay, you can see the yellow highlighted part that we are able to get it. Okay, so this is what we have to do if we are getting the word. Okay, one more important thing is C. A and B are horizontal adjacent. Similarly, B and C are horizontal adjacent. This double C is vertical adjacent. Okay, so this is what I was trying to say here. When we say, yeah, the adjacent cells are either horizontally or vertically adjacent. Okay, that's what I meant to say. And see here, when we are at E, we can go either to the left or to the right. Okay, so that doesn't matter. When it's horizontal, it can be either left or right. See, in this case, D is to the, left of E. Okay, as you can see here. Okay, you can have also got the same thing when you have, tried to go to the right. So horizontally basically means either left or right, provided the index is within the range of the board. Okay, similarly when you say vertical, it could be either up or down. There is no restriction on that. Only restriction is the diagonal one. Okay, we cannot take the diagonal one. Similarly, the same thing is here. You can see S double E is also here. Okay, so this question looks simple. Okay, before that, let's see the constraints. M and N can be between 1 to 6. Okay, that is the maximum size of the grid can be 6 cross 6. Okay, that is 36, letters will be present that in the max possible case. Okay, and the word length will be of at max 15 length. Okay, length of 15. Before you can, I'm sure that this kind of questions would have already solved if you have been practicing lead code for some, good time now. But let me quickly give you some insights here. First of all, while seeing here, you can itself understand that there is some, traversal involved in this particular matrix. Okay, that is true. But let us see some other side of it. This side you will get to know only if you solve it. Okay, this I think is the 74th edge case which I have taken for you to understand and explain why we need backtracking here. Okay, so see this example. This is again a matrix. Okay, I'm not able to zoom further. Yeah, I hope you can see now. Okay, this is the Edison matrix. This is somewhere, I can say the test case number 74 or something in the line of 70s. Okay, so this is one of them, and the string we'll have to cover is double A and B. Okay, so can you quickly tell me whether it's possible or not? You can see here it's possible. Okay, when I start from this and go towards here, I have double A, and then I will have a B adjacent to it. Okay, now see one thing here. See, when I am at this double A, okay, when I am this A, okay, now what could be the possibilities? Okay, from this A, I can move towards the right as well, because see, double A is there, right? Double A is towards the right as well. But if I move towards the right, okay, I will not have a B after that. Okay, from this particular A, I cannot have a B adjacent to it. So this particular traversal is of no use. Similarly, from this particular A, if I move towards the top, okay, for example, see this A and this A. Okay, I want to say this A and this A. Okay, again, when I am at this particular A, I do not have a B adjacent to it. So again, this traversal is of no use to me. The only possibility is from this side start moving towards the left, and then I move towards the down one. Okay, towards the vertically down side. Okay, in that case only I will get double AB. So this tells us that for, see, even for a single index, if there are multiple possibilities to move, that is towards the left, towards the right, towards the top, towards the bottom, in that case also we'll have to explore all the possibilities before concluding that we cannot do or we can do. Okay, so this basically what I want to say is, I want you to build the context of why this question needs a backtracking approach. For example, see, let us say our code by default moves towards the right, searching starts towards the right. It will move like this, and it has found a match. Okay, it has found a matching here. Okay, after the first A, it has found the second A matching, but it will not be able to find a B. So it should not conclude that, yeah, this is not a valid one, we should move to the next index. Instead of that, you should try all other possibilities as well. Okay, for example, moving towards the left as well, you should have tried that also. This is the example of backtracking. Okay, if you find one of the possibilities not working, you should be in a position to traverse back one step and continue with the other possibilities. That is what is backtracking here. So there are various ways to implement this. I have implemented it in this way. Okay, so what I'm doing is, see, this is the starting code of it. Okay, what I'm doing is, I'm going through each of the indices. Okay, each of the indices I'm going to, okay, single indices. Okay, if the first word matches, that is, if the first word matches, in this case, this is the first, this is the first letter, and this is the first letter. Okay, if they are matching in any set, I am calling a function. That's what it is. If the first letter matches, okay, I am calling a function. Okay, in that function, yeah, now I can just zoom out and show you the whole code. Okay, this is the whole function. Okay, this whole function decides whether we have got the answer or not. Okay, let me explain you that. I am taking the dimension of the board as and okay, as they have mentioned in the question. Okay, then I am taking a value of answer. Okay, initializing it with false. Why false? Because, see, we are assuming that answer will be false. If we find an instance where it is, we are able to get it, we will change it to true, and this is the final answer that we are going to return. Okay, I have shown you this code already. What I'm doing is, I'm going through each index. Okay, this is just a way to traverse the 2D matrix. Okay, I'm going through each cell or index of this particular 2D matrix, and I'm trying to check if the first letter of my word is in this particular index. If that is the case, I am calling a function like this. Okay, so what I'm doing, I'm creating empty set. Okay, I'm adding the index I, j in that set, and I'm passing that set as the parameter. What are the parameters? I'm yet to explain you that. Okay, I'm passing the function. So let us now come to the function. This is the function. Okay, so what are the parameters? I and j are the indices. You have already seen that. Index is the index from which we have to start matching it again. For example, see here, I have matched only the first letter, right? So that is the 0th index. So I should start matching from the first index now. That's what I wanted to convey. So this is going to be the index. Okay, next is the visited set. So you would have seen this statement that the same letter may not be used more than once. What that means is, if I have already visited an index, okay, for example, see here, I am at this particular C, right? The one, I hope my screen is visible to you. The C which is between F and S, okay. Suppose I'm at that C, okay. Now I should not go back to the other C. Okay, and that is the basic idea. See, the idea here is, let us say here A B, we have triple C's here. Okay, let us say we have triple C. What is happening is, from the top C, that is the C between B and D, I came down to the C between F and S. Okay, from there I should not go back to the C above it. Okay, that is the basic idea. That's what they're trying to say. The same letter may not be used more than once. For assuming, for ensuring that only we need a set here. Okay, what the set will actually hash, it will hash the index. That's what it is. Okay, I'm indexing, hashing the index, and I'm adding it to the set to ensure that it doesn't add it again. Okay, that's what we are doing here. So this is going to the visited set. Okay, whatever sets we have visited, what is the whatever pairs of I, j visited, it will be part of this particular set. Okay, what I'm doing, I'm checking if see, this is the ending condition, will come to this later, but here this is the displacement. That is to, for let us say I'm at I, j. What are the other possibilities I can move? That is, what are the adjacent cells I should be considering? This is the ones. Okay, I can go either to the right, one, that is 1 unit towards the right. I can go 1 unit towards the left. I can go 1 unit towards the top, that is the vertical top, vertical above it, or I can go 1 unit towards the bottom of the current index. Okay, that's what I'm going to do. So yeah, now I will go through x comma y of each of these things. Okay, so for each of these I will go through x comma y. Okay, I am calling the x, these two, as I'm calling it x and y, right? What I'm doing, I am adding x to I, and I am adding y to j. Okay, I am calling the new indices I, comma I, double I and double j. Okay, what I'm checking, double I should be in this range. Okay, that is, it should be greater than or equal to 0, and should be less than m. Okay, similarly, double j should be in the range of n, that is, it should be greater than or equal to 0, it should be less than n. Okay, next I am checking if this particular pair is not already visited. Okay, only then go to the next condition. What's the next condition? Just a second, I will zoom out. Yeah, what is the condition? If word of index, that is the word, this is, I already passed the index, right? That is the next index to be matched, should be matching it. Okay, board of double I and double j should be equal to word of index. Okay, if that is the case, then there is a possibility to explore further. What we will do, we will add it to our visited index. Okay, we'll add I, double I and double j to the visited, and then we'll call, we'll do a repetitive call the function. Okay, we are basically doing a recursion here. We are again calling the function inside the function, okay, and we are starting another loop out of it, okay. This is what we are doing here, and after we come out of it, we are removing it from the visited set, okay. Remember, I'm not passing, I'm not doing a soft copy here, something like that. I'm passing an instance of the visited array, okay, as you can see here at the highlighted part. After I do that function call, I'm again removing that part from here so that it does not impact the processing of the further indices, okay. As simple as that. Now I'm removing it, okay. This is what I will do. This will ensure this. See, this is how I'm implementing backtracking here. Okay, there are many ways to do it. This by logic doesn't seem to be a backtracking one, but it's equivalent to backtracking. That's what I will say. Okay, this is what I will say. After that, what I will do is, and yeah, that is it, okay. Then what will happen, it will go to, this is the ending condition, right? What will happen is, see, I am always passing index plus 1, okay. There will be a time when all of the word, and that is all the letters in the word are processed. Then we will come where a time will come where index is equal to the length of the word. In that case, we can assume that everything is processed, okay. Remember, this condition will only work if, yeah, if they are matching, only then this particular function call will be made. So be assured that whenever we are reaching an index which is equal to the length of the word, we have already processed each letter in that word, okay. So we can make answer equal to true, okay, and then we can return from the function, that is we can come out of this function, okay. That's what I'm doing here, okay. In every other case, yeah, this is the function, right? We are coming out of the function, okay. So here was the initial call made, right? Yeah. So I'm, after coming out of that call, I'm checking if the answer is true, then I'm returning the answer. If this part is not executed, then finally we will return the answer here. Most probably it will be false, okay. So if it is true, it will return here itself, as simple as that. So this is the one. Let me quickly run this and show you. This works, and yeah, this is the test case which I was talking about. Even see for the back, this particular test case basically called backtracking, and I've shown you the same thing here, okay. The same thing here, it works for this as well. As you can see, it is matching with the true, okay. So yeah, fine, that was all for today. I will give you this code maybe in the comment section. You can take it and try it of your own. And yeah, this was a good question. It seems easy, like it seems just like a traversal one, but it's not easy. And remember, you might be thinking that, yeah, in this particular approach, how I'm optimizing it. See, optimization comes, I agree that it is not fully optimized, but remember here, see the constraints here. They are saying that M should be within 1 comma 6. That is the maximum. The dimension of the grid can be 6 cross 6. That is 36 elements. So for this particular space, I guess this solution itself is enough. We don't need to optimize. And by the way, I don't see there any other opportunity to optimize. Yeah, they are talking about these things, where we are pruning the things, and yeah, this can be done, but again, this will not be a easy thing to do, especially for when we are knowing that the dimension is going to be like this, okay. Maybe if the dimension is bigger, then yeah, as they mentioned, for a larger report this will make sense. But remember one thing, it also depends on the size of the word given to us, okay. For example, this, if the size of the word is smaller one, then maybe pruning will be of some use. But I don't think it will be of much use if the word itself is such a big one, okay. So let me know your thoughts and comments. Maybe if you have an idea, we can discuss that further regarding this pruning. But I feel that these things are not needed when we are sure that the grid can be of this particular dimension, which is really small actually, okay. And they've also fixed the word size to be 15 at max, okay. So this was all for today. This, I will give this code in the comment section, and also you can let me know that if you have a better code than this, we can discuss that further. And by the way, the editorial section for this particular thing is locked, and that is one of the reasons why you know I thought of making this video, so that you can get an initial idea of how it is being done. See, basically, we would have done this, but as I mentioned, if you're not aware of these things, that there is also a backtracking involved, I'm sure that you will not be able to code this in the first go, unless you are aware that backtracking is needed in this course, in this example, because the example which they have given seems to be very very simple one. Okay, that doesn't need any backtracking as such. So, yeah, friend, that was all for today. Uh, Please comment your doubts in the comment section below, and if you like my words, please do consider subscribing to my channel. There are lots of videos coming. Stay tuned. And yeah, goodbye. See you tomorrow.